This is the beginning of chapter 13, and chapter 13 and 14 are all about wave functions, and this should all be generally new stuff to you, but you get to leverage all of your things that you know from the past. This is a big topic in pre-calculus, so the fact that we're covering in algebra 3 should make things easier in pre-calc when you get to these sections. So first we're going to talk about this lesson 13.1 is the properties of periodic functions. So you should be able to identify cycles and periods of periodic functions, and you should be able to also identify or find the amplitude of a periodic function after today's lesson. So you may ask, well, what is a periodic function? Well, it's kind of like what you saw in the warm-up. It's a function that repeats a pattern of y values or outputs at regular intervals. So it keeps repeating itself at regular intervals, and one complete pattern is called a cycle. So periodic behavior is behavior that repeats itself over intervals of constant length. So just some periodic functions that describe natural and physical phenomenon. Okay, there's all sorts of things. This is why this starts to be kind of a cool topic. For instance, orbits in space. Daylight, in terms of being dark and light, that's a sinusoidal wave. Heart speeding. If you just put a sticker on your tire and started driving, the sticker would move up and down, but as you think of traveling, it would actually go up and down and up and down and kind of travel like a wave function. Sound waves, radio waves, actual waves in the ocean, right? All of those things, tides, all of those things are periodic functions. And I use my daily phone app for the Weather Channel. And if you look at temperatures, now, of course, temperatures do vary from day to day, but basically, let's see if I can get it up here quickly. You can kind of see for a daily temperature thing that over time, it's kind of like, that will actually show, it's kind of like a wave function, right? It goes up and down like that. That has a forecast for January 2020, in case you're watching this video some other time. Okay, so I'm going to pause and I'm going to write some of those things in there so that you can write them in too. All right, so I listed some of those on there, so you just kind of have some things to write down there. You can pause it and fill those in. So problem 1 says here, to analyze each periodic function, identify the cycle in 2 different ways. What is the period of the function? Okay, so the period is the kind of the x distance, how long it takes it to repeat itself. And you can start, like I can go from here, I'm going to go all the way along here, and it's going to start repeating itself right here again because it's starting to go up again. So the period there is going to be 4. Okay, 4 units. And it doesn't ask, but let's do the amplitude right now. The amplitude is how high it is, but it's like half the max minus the min. So that's kind of the next thing. So you kind of look at it's going all the way from 2 down to -2, but you only look at half of that. So we're going to say the amplitude is 2. We'll have some more practice on that in a second. All right, let's take a look at this one. What is the period of this function? Well, I'll start from the high point. So from there to there, how far is that? We're going by -1. So it looks like this is -3 in terms of the x value, and this is 0. So the period is going to be 3. And it does the same thing for the next one. You don't have to pick the one I picked. You could have gone from 0 to 3 here, said, oh, that's 3 long as well. So it doesn't really matter. Okay. Next page here then, if you look at these, what is the function periodic? Okay, so remember the y values have to repeat in order for it to be periodic. So when you look at this one, it's going down and it's not repeating. So it's, it never is this high again. It keeps going down and down. So it's almost periodic because it seems to kind of follow the same wave function. But this one you can say it is not because the y values are not repeating. Sorry, function. Sad. The next one, it's a weird looking thing, but if you kind of look at what's going on here, you start at this high point here. Again, you could start anywhere, but I'll start here. It goes down, starts coming back up, does this little jiggy jog, and it's back up. And then it does the same thing. It looks like it goes down, does a little jiggy jog, and goes up. So I would say, and we don't know exactly what happens here, but we're going to assume it does the same thing as it was doing right here on this side. So we could say that this is periodic. Using B, what is the period? Well, again, you can pick a spot. I often do high points. So max to max there is goes from 0 to 10. So the period is 10 units. All right, I said we talk about amplitude today. Amplitude is half the max Y value minus the Y min value. So like in this one we did down here, okay, from the half this value, so you're going from 2 down to -2, half of that is, well, so that total is 4, half of that is 2, so the amplitude was 2 there. So what is the amplitude of B? If we go back to look at this one here, it's going from, it looks like, I'll change my color here, from -4 up to 4. You do have to be careful with these graphs from the book because they do sometimes one box is not like 1 unit. It's different than that. So from 4 to -4. So again, if you're going to do like an actual calculation, and sometimes you do need to do that if it's not centered on the x-axis, okay? But 1/2 of 4 minus -4, and it would be the absolute value of that, whatever that is, and that's going to be 1/2 of 8, which is, as you know, 4. Again, if it was shifted up or something like that, and you were going from the Y value of 2 up to 10 or something like that, or even like this one here, B, this one's not centered on the x-axis, so you actually have to subtract. This one would be a good one to do the amplitude for this one. Maybe there'll be some, actually there's good ones on problem 3, but we'll just do this one quick. Your amplitude would be half of the max, which is 1, minus the min, which is -2. So 1/2 of 3, which is 1.5. So the amplitude is 1.5. All right, now if we go to these, what is the period and amplitude of these? I think you should pause here and see if you can do these yourself, and then we can go through them together. On a problem like these, anytime you get weird things like this, you know, you're going to assume that's like 3 there because you don't have, you know, we can't say exactly, but it looks like it's halfway in between the box, so we'll say that's 3. All right, go for it. All right, you can check your answers there, but just fairly straightforward. I do say, if I recall this book, some of the examples and the problems have really a lack of variety. Like all of the amplitudes for these 2 problems are all 1.5. Like I have no idea why they all end up being the same. They could have definitely given us some different numbers there, but whatever. So, all right, that is it for lesson 3-1. Go ahead and do the exit ticket and see how you do.